Hi everyone, good afternoon. This is Vittorio Cioe from Oracle MySQL, and today I'm very proud to be here with you to talk about design trends for cloud-native applications with MySQL. So before you ask the question, I will answer, who am I? I am MySQL and Linux user since 2006, so quite some time apparently, almost half of my life. And I have been working at MySQL in the last 3 years. So for the last 3 years, not only Linux, but also open source databases. And previously, I've been doing other things like security, APIs, and so on. I am originally from Italy, but I live in Warsaw, Poland. That's where my love for traveling comes from. So today we will discuss some of the trends and challenges with cloud-native applications, and we will see how MySQL embraces those challenges, and we will analyze some very simple use cases. It won't be a long talk, I promise, so there will be also time for questions. So, over the last 40 years, the landscape of application development has changed. Everything has changed, from the development processes, the application architectures, the deployment methodologies itself, and the underlying infrastructure. So we went from what was waterfall, monolithics on physical servers in data centers to what it actually is: DevOps, microservices, containers, and everything stored on the cloud. And the glue of all these new development methodologies and deployment trends, it is actually the DevOps methodologies, which tie together all of these very new trends and methods. So we go from the code phase to the build phase, then deployment, testing, securing, monitoring. So we go really from development to operations and all the way back. So we can see how cloud native and DevOps are two faces of the same coin. But with cloud native, and some challenges came, especially when it comes to databases, because cloud native has introduced a lot of new methodologies and that's embraced a lot of novelties, but database, it's a kind of object which, adapting to the time, remained substantially the same over the last 40 years. So cloud-native applications, especially when they are related to databases, face three main challenges, like a lot of technologies. So each database is using proprietary APIs for access, and each database can be different. Let's think about relational, non-relational, columnar analytics, and all of these kind of things which we day by day meet. And also we are coming from the fact that we have a lot of technologies. We have the second challenge, which is that cross-technology data propagation. It is indeed difficult because those different technologies are all speaking different languages, and actually, if we want to propagate data from one data store to another, very often we have to go via some middlewares or at least some translation layers. So it is not trivial at all. And the third thing is that if we have what allow me to call a zoo of technologies, it is very difficult to manage and secure them all. So we find ourselves today in the cloud-native landscape when it comes to databases with different technologies which speak different languages, a different way to manage the data, and we have to interoperate them all, and we have to manage and secure them all. And here is where the challenge comes from. So let's see how MySQL responds to these challenges and integrates with the new development trends of cloud native. So basically, to embrace a DevOps approach, we have to do it in 3 phases. There are 3 phases which compose the full DevOps approach, and they are code, deploy, and secure, or secure, deploy, and code, or deploy, code, and secure, because in the end, this is an endless circle, which somewhere at the very beginning starts from coding only for iteration 1, but then it is an endless circle, and it is a flow of activities that never stops. So we have understood this. From the point of view of code, MySQL is pretty much omnicomprehensive because it goes through a powerful SQL language to integration with CRUD operations for a NoSQL access to data using JSON data type, and automating the coding operations and testing with APIs which have been embedded in connectors and in tools like MySQL Shell. And it makes available a full package of connectors for all of the main programming languages. So when it comes to the coding, whether you choose SQL relational access to data or NoSQL access to data, you will find one of the solutions, regardless what your choice actually is. Then, about the deployment, we have 3 different approaches in cloud native applications, which are, I would say, all of the 3 valid, and all of the 3 have pros and cons. So the approaches are the following. When it comes to the platform, we have a question which we have to answer to. So, do we put the database in the containers infrastructure or in the virtualized infrastructure? Then when it comes to the storage, do we store the data inside the containers or do we store the data in external storages? And when it comes to the functionalities which I need to deploy, do I choose single specialized smaller databases or a bigger multimodal database? Because I might have, for example, a key value store, a relational database, and a documental database, and I can choose to deploy in 3 different databases, maybe 3 containerized services, or a bigger multimodal database. Well, what do I do? So regardless of what the choice is, since we understand that there are pros and cons of any of those choices, and they are all good and all valid, from the point of view of the platform, you can deploy MySQL in a physical infrastructure, in a virtualized infrastructure, in containers, or very happily in the cloud. When it comes to the storage, regardless of where you will store your data, you will have access to it, since the database process can very well integrate with physical storage, with container storage, or with cloud storage. So there is versatility from the point of view of the infrastructure and from the point of view of the storage. What about from the point of view of the functionalities? So from the point of view of the functionalities, since we have previously discussed there is absolute versatility, you can actually choose. If you want to deploy 3 specialized databases, for example, for JSON, key value, or document, or relational, or if you want to deploy a bigger multimodal database, and do not worry about the performance, since actually MySQL in the current version can cover from the easiest to go with performances from the most severe performance requirements, as is it witnessed by the several big companies which like Facebook and Booking.com, which are actually using MySQL as the fundamental of their database infrastructure. So if we don't need to worry as well about high availability, since we have 3 different solutions ready-made and available. So they are InnoDB replica set, which actually is an automated way to deploy the classic asynchronous replication. There is InnoDB cluster, which is semi-synchronous replication with automated failover and conflict detection. And there is NDB cluster, which is a separate storage engine, very good for telecommunication payments and anything which is real-time, which is in memory, auto-sharded, and which allows both SQL or key value access to the data. So whatever your high availability requirements are, there is a solution. About security, we do really care about security, and we support it with the Enterprise Edition, where you can find several very important security plugins like Enterprise Firewall, encryption, and data masking. And we also use administration, providing audit plugins and monitoring and backup solutions. So as we have seen, regardless of the cloud native journey which you decide to take, MySQL, it has all what it takes to fully support you and to adapt to your cloud native journey. Let's see now in the last minutes, some sample use cases. So I want to propose you about 3 use cases, which are like setting up a microservices-based infrastructure. So what happens if everything goes microservices? Like porting the application stack, including the database components to containers, automated deployments, and avoiding vendor lock-in. And also the challenge of this case, it is persisting the storage to containerized database. Then I want to propose you also another use case, which is Modernize a monolithic application. We'll see how it is possible to break down a monolithic application and then create a cloud-native real-time application for IoT devices. So, to set up a microservice-based infrastructures, it is very easy. Whatever cloud provider I choose, Kubernetes or OpenShift container engine, and I can very easily, via the automatable scripting available at any cloud provider, I can very easily deploy MySQL in containers, since there is a container which is natively available, and I can externalize the storage to storage arrays or to object storage or block storage to make it persistent, so to some cloud storage. And if you have worked with containers, this is very easy to configure, and it is absolutely fault tolerant. In the second use case, we modernize a monolithic application. So we start from this very aged monolithic application where we have the user interface plus application all bound in one, and externally we have the database. So we go through a process of separating, and this is a development process of separating the user interface and to separate the middleware, like the application server and the data access layer. And here we can decide. For example, we can have a relational data store and a JSON data store. And we can decide if we want to deploy two separate database services, maybe both of them separately highly available, or if we want to deploy one database service, making it highly available. For this example, I have chosen to deploy the application in containers and the database service on what we have seen before to be an InnoDB cluster on a cloud infrastructure separately. I could have deployed it also on container. So in this example, we have broken up a monolithic application to be containerized using an automatically highly available MySQL data store as a database service. Last but not least, absolutely very fitting to the cloud native world, it is a real-time application for IoT devices. So I can have IoT devices in mobile phones, like smartwatches, cars, in the house, like fridges, washing machines, and so on. And they could communicate with a cloud network somewhere. And I can have, for IoT devices, since the main requirement is real-time, the solution I have chosen to deploy, it is NDB cluster. So in-memory, auto-sharded database, since IoT devices are producing a lot of traffic and a lot of data. And they need to communicate in real time indeed. So I can choose that the application communicates to the data store using the so-called NDB API, which is an API which realizes key value access to the data which are stored in memory. And I have deployed some MySQL nodes as a complement in containers for easy administration, let's say. So I was able in the end to deploy a cloud native real-time application to communicate with IoT devices using containers, using MySQL nodes in containers, and having externalized the data and the NDB cluster nodes where the data are being kept to bare metal machines, in this case cloud bare metal machines, in order to get maximum performances. Of course, I could have put all of these also in containers, since also this NDB cluster technology, or MySQL cluster technology as it's differently called, it can run as well in containers. So we are about to finish. At the end, the message which I wanted to convey is that yes, cloud native trends are changing, are shifting, but MySQL, it is natively reintegrated and ready to adopt them all. Are there any questions? If there are no questions, I would say start building now.